Hello everyone, this is Alexander from Galileosky. In this video I'll tell you how to set up auto informing for the driver. Let's have a look at the example of a ready-made script that monitors the driver's behavior on the road. All Galileosky devices that support SD cards also work with audio files via the external speakers. We recommend you to use speakers with an impedance of at least 8 ohms. The device supports audio files in WAV format, also mono, 16 kHz and 16 bits. The audio file duration should not exceed 4 minutes. Audio file playback can be used in the autoinformer, eco-driving system, as well as in any EasyLogic scripts. Let's look at one of the scripts for eco-driving and download the ready-made algorithm from EasyLogic templates on the website. We go to Galileosky.com, put the mouse over the training button in the upper part of the window and select the EasyLogic templates. Mark the eco-driving item and select the last algorithm in the proposed list. Sound notification to the driver about violation of driving style. Press the download button and save the algorithm in any convenient place. Now launch the configurator and switch to the EasyLogic tab. At the top of the window, select the Open button and find the downloaded script. Now we can see how the algorithm is built and, if necessary, change its parameters. As you can see, first of all, the device checks whether the coordinates are determined, and then it checks the current parameters. They are acceleration, angular acceleration, and speed for exceeding the set limits. If the limits are exceeded, the device will play an audio file with the needed sound warning. Pay attention that acceleration parameter is checked twice. In the first case, the algorithm checks the forward acceleration. In the second, negative acceleration. The acceleration parameter during braking, accordingly, has a negative value. Therefore, we also need to double-check the angular acceleration to track left and right sharp turns. Let's add a branch for checking the angular acceleration in one direction and in the other. Have a look that acceleration in algorithms is measured in millimeters in second square. You can change the algorithm if you want. Let's suppose that you need the device to write an additional point in memory in case of any violation and describe the specifics of this violation in a custom tag. To begin with, let's make sure that in the case of a sharp acceleration, the data will be written to the user tag with a value of 1. In the case of sharp braking, with the 2. In case of sharp turn, we write 3, and when overspeeding, 4. It is not difficult to add these functions. Let me show you how. To begin with, after each check, add a record of the corresponding tag. I remove the true branch lines after each checkout block and add the right tag blocks. Select the user tag 0 and indicate the corresponding values for each of the violations and continue the chain. Now you need to add a block for recording a point in case of violation. We remove links after playing audio files and add the save point block. After the point has been saved, we need to reset the value of the custom tag to 0 because the violation message has already been entered into the device's memory. Now add missing links and that's it, the script is ready. Pay attention that the script already contains audio file names that will be played after each violation. You can assign any name to your files if needed. You can change the values of the script parameters at the editing stage or using the appropriate command. The algorithm contains a needed block. You can send a style command and specify values for the acceleration, braking, angular acceleration, and speed parameters separated by commands. That's it, the script is ready. We save the changes and load them into the device's memory. As you remember, the script starts with the device start block, so we need to restart the tracker. Don't forget to mark the user tag with 0 for sending to the monitoring software. We do it to determine the violation specifics. Now we need to record the audio files with warnings. You'll need a microphone and any audio recording software. Let's record the warning. Overspeeding. Okay, now let's figure out how to prepare files for uploading to the device. In the configurator, go to the Road tab. In general, this tab is needed to create and edit bus routes, but on the same tab, you can import audio files. The function of converting audio files is available in the configurator since 4.25.0 version. We insert the memory card into the card reader and select it as the place to save the audio files. Next, press the plus button and select the files to convert, and then press the Start Conversion button. The audio files are converted and saved on the memory card. We insert the memory card into the device. Our algorithm is fully operational. Now we need to configure our object on the monitoring software to process new information. For example, we decided to take the violin software. Now let's create a sensor based on custom tag 0 and specify messages for the corresponding values. This can be done here on the Sensors tab. Well, now we are completely ready to test the algorithm in real conditions. Okay, we placed the device on our Nissan Note car and connected antennas and speakers to play warnings. The speakers for playing audio files are connected to the device outputs Vol 0 and Vol 1. Let's check how our device will react to, for example, excessive speeding.
Overspeeding. Harsh braking.
So, as you can see, the device reacts correctly to overspeeding and when I brake in too active. Now let's check how our device will react to sharp cornering.
Sharp cornering. Sharp cornering. Sharp cornering. Harsh braking.
That's it. As you can see, I did 3 actions: overspeeding, harsh cornering, and harsh braking. And the script works correctly. That's it. Okay, now let's check how similar actions look from the violin software side as an example. Okay. Our device is configured to record points every 10 seconds. But here we see additional records and messages about sudden violations. Here we see a record of overspeeding, harsh braking, and sharp cornering. So we figured out how using a ready-made algorithm implements sound notification function. Also, we added the function of data sending to the monitoring software, and as you can see, everything is quite simple and doesn't take much time. Let me remind you that you can always change the functionality of the ready-made algorithms according to your tasks and add the necessary functions. That's all for now. Alexander from Galileosky was with you. Goodbye.